All right, so today we're going to review our exponent properties and rules. Now, before we start looking at the different properties, the first thing we need to discuss is some of the lingo we're going to be using here. So remember, the way exponents are set up, we have some base value, number, variable, right? And it's raised to some exponent. Okay, so you're going to hear those terms, base, exponent, quite a bit through this. Now, when I have the same base and I'm multiplying them together, I want to add my exponents. Okay, so that's the product property. When I'm multiplying two things with the same base, I add the exponents. So, first example here, I see I have x as a base for both of them, right? So my exponents, 6 plus 4, I would have x to the 10th power. Number 2, base 2. So adding my exponents, I would have 5 2's. Now, when the base is a number and it doesn't simplify into some gigantic answer, like 2 to the 5th is reasonable, okay, we want to make sure that we simplify that. And that would be 32. Now, if it was something like 2 to the 42nd power, I would just leave it as 2 to the 42nd, okay? So if it's within reason to simplify, do so. Now, looking at number 3, I have multiple bases here. So I have a times a, so those same bases I'll combine. And that gives me a total of 13 a's, so a to the 13th. And then I have a b and a b, so 7. Remember, when there's no exponent, there's really that 1 there. So I would have b to the 8th. Now, power of a power. So I have my base inside with an exponent, parentheses to another exponent. Similar to when we have a number out front of my parentheses, I want to think about distributing, which means that I am multiplying. So, bringing that 5 to the inside, I would have x to the 20th. Now, number 5 is where we actually have to think about like distributing that 3, right? There's 2 things on the inside of my parentheses, s to the 4th and t to the 7th. So I want to bring that 3 to both of those exponents and multiply them. So I would have s to the 12th, t to the 21st. And same thing happens when I have a fraction. It's just I'm going to distribute the 3 to the numerator and the denominator. And that would leave me with a to the 6th, b to the 15th. Okay. Quotient property. So when I have same bases, one on top, one on bottom, I want to subtract. So I see that I have 2 to the 8th on top, 2 to the 6th on bottom. So that would leave me with 2 squared on top, which would be 4. So another way to think about when I'm dividing, right, we want to think about canceling things out. And when I'm canceling things out, whatever has the bigger exponent. So if the bigger exponent's on the top, that means that when I cancel things out, whatever's left is going to be on the top. When I cancel things out and the bigger exponent's on the denominator, then when I cancel out, my base is going to be left in the denominator. Okay, so what I mean by that is, if I had something like, right, I would cancel out and I would have 2 to the 6th left, but here is my bigger exponent. So I would have 2 to the 6th left on the bottom. And that would be 1 over 64. So that's another way you can think about it. Looking at example 8, x to the 9th over x to the 6th, so I would have x to the 3rd left on the top. And I have y to the 5th over y to the 3rd. I would have 2 left, So y squared, and it would be left on top because that's my bigger exponent. Zero is the easiest property, but it's the one that most people overlook. Anything raised to the 0 power, I don't care if it's a number or a variable, it is always going to equal 1. Always. Okay, so even if you had something like negative 3x to the 5th y, all raised to the 0 power, that 0, if you think about our power of a power property, right, I would distribute it to everything inside. So that entire thing's raised to the 0 power would just equal 1. Okay. Negative exponents. Whenever I see negative exponents, I want to think about flipping its side. Okay, so if the negative exponent's on top, I'm going to bring it to the bottom. If the negative exponent's on the bottom, I'm going to bring it to the top. So looking at 11, this thing's on top, right? I always circle my negative exponents. So I'm going to bring that thing down. I would have 1 over 2 to the first power, which is just 2. Now, for 12, I'm going to show you 2 ways to do this. So, first way, I have 4 over 3 to the negative 2. I'm going to distribute it inside to everything. So I would have 4 to the negative 2 over 3 to the negative 2. Now, I can't evaluate negative exponents, right? That's not a thing. So I have to flip them first before I can evaluate. So I see that I have a negative exponent here, so that's going to go down. I have a negative exponent here, and it's going to go up. So I would really have 3 squared over 4 squared. Now, the whole point of flipping it to the other side, that gets rid of the negative. So now I can evaluate. 3 squared would be 9, 4 squared would be 16. Okay, so that's one way to do it. The other way to do it is to flip it right off the bat. So instead of 4 over 3 to the negative 2, I'm going to flip my fraction and make it positive. Then I can distribute. Okay, so either way you want to do it, it'll get you the same answer. I'm going to stick with the first way, distributing it, because when we get into more complicated problems, sometimes when we distribute the negative, it takes care of other negative exponents. We don't have to flip as much stuff. Last property or rule are my rational exponents, so my fraction exponents. When I have a fraction exponent, the numerator is the exponent, the denominator is the root. And there are 2 ways we can write it. Okay, the exponent can be on the inside of the root or on the outside of the root, like it is here. Okay. So, looking at this first one here, I have the power of 1 and the root of 2. So a root of 2 is just a square root to the first power, right? And that would just be the square root of 4, which is 2. Now, when we get to more complicated problems, like number 14, we have 2 options. And we're always going to investigate these 2 options and ask ourselves, which one's easier to evaluate? So option 1 is when I have the power inside the root. So I have the cube root of 8 squared. Second option, cube root of 8 squared. Now, when I ask myself which one's easier, I always pick the one where the numbers work out in the smallest way possible. This one's not too crazy because it's 8 squared. So if you were to choose the first option, you would have the cube root of 64, which would equal 4. The smaller way, the cube root of 8 is 2, and then 2 squared is 4. Okay. So sometimes you'll want to take the power first to make the problem work. Sometimes you'll want to take the root first so that the numbers don't get gigantic. It kind of just depends on the numbers you're working with. So now that we have all of our properties talked about, let's look at some examples of navigating through some of these problems. Now, before we start looking at these problems, first thing we need to talk about with these is that there's always more than one way to do these problems. Okay, so the way I do it might not necessarily be the way that you think about doing it, and that's completely fine, as long as you work it down to the same answer. But with that being said, I'm going to try and show, I guess, the easiest way of doing it. So with that in mind, looking at 15, I'm going to start inside of my parenthesis. Okay, so I'm going to try and cancel out some stuff first and deal with that division, then deal with that fraction exponent. So when I look on the inside, I see that I have c to the 5th over c to the 3rd. So that's going to leave me with c squared on top, right? Looking at the d's, I have d cubed on top, d squared on bottom, so that's going to leave me with 1d on top, all to the 1/2 power. Now, we can distribute that 1/2, and we get 2 times 1/2, which would be c to the 1st, and then d to the 1/2. Now, that is an acceptable answer. Okay, if you wrote it like that, awesome. If you went one step further, though, and said that, oh, well, 1/2 is really the square root of d, you could have written that as your answer. Both of those are acceptable. Okay. All right, 16. I have an exponent outside my parenthesis. I don't have common bases inside, so I can't simplify anything in there first. So I'm going to go right into distributing. So I have p to the -6 over q to the -9. So I see negative exponent here, that's going to go down. Negative exponent here, it's going to go up. So I would get q to the 9 over p to the 6. All right, 17. 17 is one where we need to talk about, well, which method would be better. So first things first, I see I have a negative exponent. So I'm going to bring that thing to the bottom. I'm going to come over here a little bit, though. Okay. Now, I'm going to talk about 64 to the 2/3 power. So we have two options, right? We have the cube root of 64 and then squaring it, or we have the cube root of 64 squared. Now, I don't know what 64 squared is right off the top of my head, so I'm going to choose to do this one because it's going to make my number smaller. So that's what I meant by, we have to figure out, well, which one's easier to deal with. 64 squared is not easy to deal with, so I'm not going to deal with that. I'm going to deal with the cube root of 64 and then squaring it. So the cube root of 64 gives me 4. And then 4 squared is 16, and I'm done. Okay. All right, a couple more here. So again, nothing inside the parentheses to simplify, so I'm going to distribute that 1/3. So I would have 27 to the 1/3. 6 times 1/3 would be a squared. So let's see if I can do anything with 27 to the 1/3. So that would be the cube root of 27. And the cube root of 27 is 3. Okay. 19. I can't deal with my quotient property yet, so I can't cancel things out until I have everything on the top together as much as possible. So I need to break up those parentheses. So I'm going to distribute the 2 to those two, and I'm going to distribute the 5 to those. So I would get a to the 8th, b to the 12th times a to the 10th, b to the 5th. Now here, technically, you could start canceling things out if you wanted to. I like to combine everything on the top first, so that's how I'm going to do it. So I have a to the 8th and a to the 10th, so I have a to the 18th, And then I have b to the 12th and b to the 5th, so b to the 17th. Now it just makes my canceling easier. So, canceling out my a's, I would have a to the 11th left on top, right? Because there's my bigger exponent. And then canceling out my b's, I have b to the 17th and b to the 19th, so I would have b squared left, but it would stay on the bottom because that's where the bigger exponent is. Now, number 20. The mistake people run into with this one is they just jump right into distributing that -1. But remember, when I have a plus or a minus sign in between my two terms, I can't distribute. So I'm going to have to flip this negative exponent. So I'm going to bring that down to the bottom. So I would have 1 over 2 to the -1 plus 2 to the -2. Now, again, I can't split up that denominator because of that plus sign, but I see that I have a negative exponent and a negative exponent. But remember, these are also over 1, sorry. So I'm going to bring that to the bottom and bring that to the bottom. So I'm going to create a complex fraction here. So this would be 1 over 2 to the 1st power. And then 1 over 2 squared, which would be 4. Now, combining or adding fractions, I need common denominator. So 1/2 would really be 2/4, right? So 2/4 plus 1/4 would leave me with, okay, and that would equal 4 over 3. Now, to talk about what I just did there to get my answer, just to refresh you a little bit, 1 divided by 3/4 can really be written like this, right? And when I'm dividing by a fraction, remember from Algebra 2, we have keep, change, flip. So that's really 1 times 4/3, which leaves me with 4/3. Okay? All right, almost done. Now, 21. 21, I have a bunch of different bases, some pretty big exponents, and this would ultimately lead to a really big number. But there is a way to simplify this thing without dealing with those big numbers. So, first thing I want to do is to rewrite that denominator. Okay, so instead of the square root, I want to make that its fraction exponent. So, I would have 2 to the 6th, 4 to the 8th, 8 to the 4 over 2. And then just to simplify that denominator before we talk about what's next, I would have this. Okay. Now, I have as bases, I have 2, 4, and 8. If I can somehow get these to have a common base, I can cancel out a bunch of stuff, and it would make this problem a little bit easier to evaluate. So if I look at my numbers, I have 2, 4, and 8. Well, those are all multiples of 2, right? So changing everything to base 2, the 2 to the 6 is already base 2. 4 is really 2 squared, and 8 is really 2 to the 3rd. So replacing 4 and 8 with 2 squared and 2 to the 3rd, I would get, instead of 4, 2 squared, but there's already that 8 there. And then instead of 8, I would have 2 to the 3rd, but there's already that 2 there. So 2 to the 6th times 2 to the 16th all over 2 to the 6th. Now I see that I have 2 to the 6th over 2 to the 6th, so you could cancel right away, or you could add the top exponents and then do your canceling. I'm just going to cancel the 2 to the 6s because they're the same. And I'd be left with 2 to the 16th. Now, 2 to the 16th gets pretty big, right? So we're just going to leave this one as 2 to the 16th. It's easier to write it that way than actually evaluating 2 to the 16th power, okay? Now, the last thing we're going to talk about are these common misconceptions that people make when dealing with exponents. A is probably the biggest one, right? So negative 2 squared versus negative 2 squared, okay? So let's see if these things are equivalent. Negative 2 squared is really negative 2 times negative 2, which gives me positive 4. Excuse me. Now, the next one, the square is on the 2, and the negative's out front. So that's really negative 2 times 2, which gives me negative 4. So these two things are not equivalent, okay? So if the negative's on the inside of the square, it's going to become positive. If it's not inside the square, so there's no parentheses there, that negative is really negative 1 times 2 times 2, okay? B, so this kind of looks at why we can't distribute when we have a plus or a minus sign when we're dealing with exponents. So if I think about order of operations, I would do 3 plus 2 first, right, PEMDAS. So that would be 5 squared, which gives me 25. Over here, 3 squared would be 9, 2 squared would be 4, which would give me 13. So again, not equivalent. So that's why I can't distribute the 2 when there's a plus or a minus sign there. Last one. Again, PEMDAS, order of operations. 3 times 2 would give me 6 squared, which would be 36. 3 squared would be 9, 2 squared would be 4, and that would give me 36. So this is why we can distribute the 2 with multiplication, because it will be equivalent. It will give us the same answer.